you hear me? I think so. Like him said, I don't remember the name, to be honest. I'm glad that everyone is awake after yesterday's after party, so no one will actually fall asleep during this talk, because I realized that it's quite early. And so the title of today's talk is Loaded Faster, Improving React Apps Loading Time and Performance. And I suppose I should say 2 words about me. So my name is Tomasz Łakomy. I will be working at Ignite as a software engineer because, in fact, I'm starting on Monday. And I came here from Poznań, and I was involved with front-end developer for the last, I think, 5 years now, so quite a long time. Okay, so we're going to talk about performance. We're going to talk why performance matters, why we should actually care about performance, and how to achieve better load times and better performance in our React apps, but not necessarily. We're going to talk about things that can be useful in general in applications. And a bit of a disclaimer before we go any further, that some things that I'm going to talk about might be obvious to some of you, but remember that everyone has a different learning curve, and things that might be obvious to one person could be, well, entirely new to the next one. Okay, so with that being said, what is the motivation? Why we should actually care about performance, apart from that we are, well, cooler than the guy sitting next to us because our app is faster. And I'm going to start with what happens when we don't care about performance, when we forget about performance. So this is an issue that was reported in Visual Studio Code repository back in March last year, so 3 months ago. So basically, the Visual Studio Code used to drain 13% of your CPU just to display a blinking cursor, because someone forgot about caring about performance. So basically, if you open a Visual Studio Code and it weren't doing anything at all, your CPU would be taken in 13%, which I honestly think is a bit of an embarrassment. So my motivation, one of my motivations, is to avoid such unnecessary and easy to fix issues like that. And another thing is that, as Paulo Coelho once said, that your users won't have MacBooks, especially as expensive as the newest MacBooks Pro. What I'm saying is that most developers are working on much better equipment than the users are actually using, right? Because most users don't actually have MacBooks, and, well, devs are upgrading their PCs or MacBooks every 2 years, or maybe even more often. So our equipment is much more superior, and we sometimes forget about that. And also the thing is that I was talking about MacBooks and PCs, but we are approaching a new shift in how we should perceive apps. Because the thing is that we used to live in a mobile-first world, and everyone was talking that apps should be mobile-first, and we should care about mobile web in the first place. I'm trying to argue here that we are moving towards mobile-only world. And the thing is that there are some apps out there currently that they don't even provide a desktop experience. So for instance, Instagram didn't used to have a web app until, like, I don't know, a couple of years ago. And also there's an example of, well, apps like Tinder, which I don't use because I'm engaged to this lovely lady over there. But if I were using, it's only available on mobiles, right? There's no need to have a desktop experience in apps like this. And this is important in a scope of mobile web apps because, for instance, Google is saying that there are more searches right now on mobile than on desktop. So if you're building a web app that your users will find from Google, it's actually much more likely that those users will be coming in from mobile than from desktop, which means that their CPUs and their processing power on their device will be smaller than the ones you use to develop your app. And another thing is that, apart from equipment, most people don't have 4G, and this is a fact. I mean, we're living in a great country, Poland, which is a first world country, and yeah, it is. But if you are building something that is meant to be international, the vast majority of users out there will be working on, in best case, 3G network. So we should absolutely think about that. And I would absolutely urge you that after you finish building your app, or even building a MVC or a, well, big feature, just to switch to your favorite browser. I'm using Chrome because it's my favorite. And switch the network conditions, switch the network to regular 3G or even 2G, and check if your app is still fast, because it might not be. Another thing is that why we should care, because parsing JavaScript on mobile is costly. And I mean literally costly, because not everyone has unlimited internet package in their phones, in their mobile phone provider. So for instance, if people have like 500 megabytes of mobile phone data, which is not very uncommon in like countries like, I don't know, Indonesia. So if your page weighs 5 megabytes, the user will be able to go to it only 100 times in a month. And after that, they will actually have to pay. And it's also costly because, like I said, the equipment in mobile phones is inferior to the ones we have on desktops. So it would take actually a bit longer to parse your JavaScript code. And also, while doing so, it might drain more battery. And trust me, user will notice when their phone is being drained because of your web application. Okay, so once thinking about performance and optimizing for performance, the thing is that there's no single way to optimize. Every single app out there is different. And so I'm not going to give you like a silver bullet to fix every single one of your performance issues, because this just won't happen. And if such a bullet would exist, I think that someone would automate it by now. So there's no single way to optimize. And the thing is that the best code is actually no code. I mean, nothing will load faster and nothing will be executed faster than no code whatsoever. And I'm not saying, of course, that we should, ship empty files to production. Of course, it will be fast, but we won't provide any value to the user. What I'm saying that it's something we should keep in back of our heads is that when you think about adding a new library, a new framework, a new, cool thing you saw on Twitter, please consider beforehand whether it's actually necessary, because nothing will run faster than smaller code base. And this is another thought, that we should care more about users than our code base, because everyone loves the good developer experience, right? Everyone wants to have newest, coolest libraries, newest, coolest frameworks. And sometimes we forget about users, and we end up with something like on this picture. I'm not quite sure if you can see it. It's actually a bookshelf which is made of books, and there are bricks inside. And this is what we get when we think more about code than our users. In general, we should ship less assets. I'm talking about fonts, images, because it's not very uncommon to see a website which has, like 50 megabytes images in the background, and also ship less codes. Especially a point about fonts, when talking about mobile web, consider using system fonts instead of making those users download a new font every single time they access your web page. Because those system fonts you have on Samsung phones and iPhones and, well, all smartphones are quite good. So there's no need to make those users download new font every single time. And there's also this cool feature that I would like you to check out is code coverage. It's available in Chrome version 59+. So basically, if you ship your website to production, you can actually use code coverage to find out how much of your code is actually being used on the web page. So this is a website of a certain JavaScript conference. So we can see, for instance, that this conference in particular ships, this much bytes of JavaScript. Basically, 67.5% of this JavaScript is not used for initial page load. So it could be optimized in some way. We should, okay, this is obvious, but we should minimize our code. And I'm saying it's obvious, but there are plenty of websites out there that they don't actually minimize code in production. So in terms of minification, I would strongly recommend you guys use Babili. Babili is a great minifier, a bit more modern than Uglify that everyone uses. And I'm going to show you why. So imagine we have this very simple class. It doesn't do anything important, like the most code I've written. And you have to actually create it, because if you wouldn't create it, those would be deleted by the Uglify or any minifier out there. So if we parse this code through Uglify, we're going to say that it's going to be transplanted into some function, and there will be some black magic involved. But if you use Babili instead, the core difference between Uglify and Babili is that Babili actually knows ES6 because it's a part of Babel. So this class I wrote before is going to be actually not parsed to a function, but is going to be kept as a class. So you will actually get smaller bundle sizes because you won't have to parse your ES6 to ES 2015. In general, ship less libraries. Like I said, consider before adding a new library to your code, whether it's actually better for the users. And when shipping libraries, always think if you should ship an entirety of this library. Because for instance, we have this example of Lodash. Lodash is a great utility library used by, I don't know, most web apps out there, I would argue. So those first two examples are incorrect in terms that the first one is actually importing the whole of Lodash. And I would say that, I don't think there's a web application that actually uses a whole of Lodash because there's like 150 methods out there and no one is able to use them all. And the second one is a bit different, but it's actually doing the same thing. So basically we're importing a whole of Lodash and we're trying to get those four methods: contact, sort by, map, and sample. And what we should do is the third example. So if you need only 4 methods from a library, consider if it's modular like Lodash and just get the stuff you want in order not to ship unnecessary code to your users. And when talking about not shipping unnecessary code, there's this great thing called Webpack tree shaking, which is available in Webpack 2.0. I think this was also possible in Webpack 1. So basically what it does, if you go like outside, this was supposed to be an outside conference, so it would be easier. But if you go outside and go to a tree, and you actually shake the tree, those dead branches that will be on the tree, they will fall down. And tree shaking does exactly that, but with your code. So basically it shakes your dependency tree, and if there are any unused imports, it will actually remove them, and it will result in a smaller bundle size. Okay, I've talked for a bit what we can do in general, and now we're going to switch to a bit talking about React, because the title of this talk was about React after all. Okay, so we could not do anything at all, because React is fast. It's fast by default, and this is one of the reasons why everyone started actually using it. And also, like we heard yesterday at the great talk we've had from the guys from NetGuru, from ColdStack, that the Fiber is coming. So the React itself will actually get a bit faster, and I think they will continue doing so. But if we have something which is useful, like it's not a to-do MVC, we're trying to actually ship it to production, make sure that we're actually shipping React version to production. Like Eddie Osmani said, that we shouldn't ship development version of React to production. We should always use Webpack define plugin to set node environment to production. This is the difference that we're going to get. So if we will ship a development version of React, this bundle, for example, is 767 kilobytes. So if we had like this very old floppy drive, you could only fit 2 of those apps in a single floppy drive. And if we actually switch to production environment in Webpack, you're going to see that the bundle is 143 kilobytes. So you could fit 2 of them in a floppy disk. And also this code will be actually faster because the development version of React is not only bigger, but it also contains a lot of checks and warnings that will make your code a bit slower. And those checks and warnings obviously are not necessary in production environment. Yeah, so this is the difference that we're going to get. So quite massive. Also, if you are curious whether your page, or any page in particular using React, is actually shipping React for production, if you have React DevTools installed, you can actually check it out by clicking on this icon. It's been added, I think, a month ago. So if you click on this icon, you're going to see a notification whether the page is using a production build of React, as it should. But trust me, there are some pages you can find that are actually using a development version in production, which is, well, a mistake. Another thing that we can do, apart from shipping React version from production, is to remove prop types from production. And this is a little asterisk over there and a little note that it could be risky. And I'm adding that because I don't want people emailing me in the middle of the night that their website is broken on production because they've heard my talk at GrillJS. And it could be risky because, well, most people aren't using prop types in runtime because prop types are necessary to validate whether you're actually passing correct props to your components, well, mostly in development. But there are some libraries out there, there's not many, but there are some of them, that are actually using prop types in runtime. This is why I said that it could be risky, it it could break your code. So this is a very simple component, and it doesn't really matter what does it do, but what it matters is you can see like 20% of this component is prop types. Like I said, they are not used in production at all, so it's quite unnecessary to have them. So this is what this code is going to look like after minification. So this is the display name, this is the component name, info button, and those are the prop types. So without even reading this code, because it's minified, so obviously it's very hard to read, but even without reading it, you can see that the prop types are 20% of your code. And like I said, those prop types are ignored in production environment by React. So you're essentially shipping that code to production. This code will be parsed by those users' machine, but it won't be useful at all. So there's this, okay, let me try to say it. Babel plugin transform React remove prop types. Oh, that was quick. Yeah, so this is a great plugin for Babel. So what it does, it actually helps you remove prop types from your production build, and you can actually save quite a lot of bandwidth by removing them. And I'm going to show you how much exactly. So this is a app I was working on. It's actually on production, and I think it's working. So this is the result we had before, 240 kilobytes. And after I've removed prop types from this example app, which is not a hello world, it's a bit more complicated, the result was 10 kilobytes less of that code. So we got around 5% less code, 5% less bundle size just by removing prop types. So I think this it's a very easy win. You can do it for free, and it shouldn't, emphasis on shouldn't, break your app. And this is what the code is going to look like after removing prop types. So you can easily see that I could nearly fit 2 of those components in the same slide. So the difference is quite good. There's plenty of plugins for Babel that I could spend like next hour talking about, but I simply don't have this much time. So I would strongly recommend those of you that are currently on your laptops to check out Babel React Optimize. It's a great collection on GitHub, which contains a lot of packages for Babel that can help you well, minimize and optimize your bundle, but also make sure that those won't break your production code, because some of them are actually quite risky. Okay, our bundle is smaller, that's great, it's actually loads a bit faster. So now we're going to talk about what we can do in runtime. So before we talk about what we can do to improve it, we need to know how to measure it, right? Because no one is going to actually sit with a stopwatch trying to find out whether your app is actually faster. So in order to measure it, how much faster your app is and how much time you are wasting or not wasting, there's this React add-ons perf, which you can use. It's actually maintained by people from React, and it's a separate package, so you can install it from npm. And what we have here, it basically contains like 8 methods, but only 3 of them are very important. So the first one is stop. Sorry, the first one is start, obviously. So you press start. You start doing some stuff on your page. So for instance, this is an example of to-do. So you added 1,000 items in your to-do list. Then you press stop. And after that, you can find out by running print wasted how much time was wasted by your application in that quick time. And by wasted, I mean this is the time that is spent on the renders that didn't do anything. So basically, the React had to re-render those components, but the DOM before and after render was exactly the same. So basically, this was a wasted time, and in this case, it was 100 milliseconds. So in terms of web apps, it's actually quite a lot. It's nearly an eternity. But if you would like to know how much unnecessary renders you actually have in your code, without trying to get them one by one by using perf tools, you can actually use a package called YDG_update. And YDG_update is a bit more talkative because it attaches itself to every single render you have in your application. So obviously, if you use it on a ready application that's ready for production, your console log will be spammed with, I don't know, hundreds of messages. That's why I recommend starting using it at the very first stages of your application development, so we will be actually able to catch those unnecessary renders and then improve them. And in general, the rule should be to render as little as possible, because every time you do unnecessary render, a cute panda dies, and we have like 200 of them left. So there's only 200 unnecessary renders left. So please keep that in mind. And the thing is that, like I said, React is fast, but those things aren't free. We heard yesterday how the React algorithm works behind the scenes, but, well, it takes time, right? React needs to do all those calculations, and those calculations are for free. So in order to avoid unnecessary renders, we should use things like should_component_update. Should_component_update, for those of you who don't know, is a lifecycle method that is run before every single render, and you can use the result of it. Basically, if you return false from this function, the component won't be rendered again. If you want to freeze your component, you can basically put return false in it. And this is sometimes useful. If you're absolutely sure that your component doesn't need to render again, you can just return false, and that's it. I would also recommend to use pure components. Pure components are the components that are function of their props. So basically, you pass in props, and for the same props, you always get the same DOM. So those components are actually quite smart, because if those props weren't changed, there's no point in re-rendering the whole DOM tree. So you can actually get a bit faster app and just move this state using many state management tools that we have, like Redux or Mobex. Another thing that we can do is to inline React element in production environment. There's another very helpful Babel package. This is called, oh god damn it, Babel plugin transform React inline elements. So what it does, currently if you write JSX like this, it's going to be parsed to React create element functions. And those functions obviously are fast, but it can be improved by switching from React create element to this Babel helpers JSX function. You are actually getting an improvement because this function inlines the result of React create element. So instead of running create element over and over again, you can actually inline some of those results and get, I think the bundle size is 1% bigger, but according to those people that wrote on this plugin, it's actually much faster for the web app. After we've done performance improvements, we might want to profile our app. And it was pretty damn difficult a couple of months ago, right? Because if you switch to your timeline in Chrome, you would see a bunch of internal React methods, and it was absolutely impossible to profile. Now it's better. I'm not quite sure if it's visible from out there, but over here, we actually have the names of our components, and also, for instance, we have that this component was updated, and it took, I don't know, 500 milliseconds. So instead of watching and looking at internal React methods, which is very difficult to debug, you can actually profile your own components, and it's much easier to work with instead of, trying to find out what the hell is React doing internally. And the last major thing I wanted to talk about, and this is something that is very exciting for me personally, is code splitting. Because code splitting allows us to give users a different bundle of code depending on their actions and the context of these actions. And I'm going to show you in just a minute. But before that, we're going to think how we used to approach shipping code to our users in the past. So, well, at the very beginning, there was nothing. And slightly after that, we used to ship a single minified app.js. So yeah, okay, the code is minified, and it was great. But then someone thought, well, it doesn't actually make much sense now, doesn't it? to ship a single file to the users, because most of this file is going to be external libraries like jQuery or Backbone at the time. And someone thought that, okay, we're going to split into two files, right? So we're going to have vendor.js with our framework and the libraries code, and app.js containing the code that we've actually written. So yeah, it was an improvement because vendor.js would be cached and it would be great. And then someone else thought, why are we making users that are on the login page download the code which will be used on, I don't know, user profile page? If the user is not logged in, there's no point of them to having this code. So someone thought about making users download different bundles of code for different routes. But we can go a bit deeper. And this is where code splitting comes in, and this is where things called dynamic imports comes in. Yeah, dynamic import. It's absolutely fantastic. I'm very excited about that. The thing is that we can actually use them today because they are currently in the stage 3 of TC39 process, which means that they will be most likely part of JavaScript language, probably pretty soon. We can use them today because they are supported by Webpack 2, and they allows us to have dynamic function-like imports in our code. They return a promise. And the thing is that instead of having those imports that we used to on the very top of our files and just import everything synchronously, you can have imports inside of your functions, right? So you can, for instance, import a library only when a component that needs it will be displayed. So there's no point, for instance, to make users download a whole of Moment.js at the very start only because we're going to display a clock somewhere. And this is where dynamic imports and React Loadable comes in. And I wanted to show you guys in a quick live demo. And I know the first rule of live demos is that it's not going to work, but hopefully it will. So this is a very simple example that I wrote. As we can see here, it's going to render a React Loadable demo over, in H1 tag. And below that will be the loadable example. And React Loadable is actually a great library because it allows us to use dynamic imports in context of React components. And this is how it looks like. So loadable example is a result of running this loadable function, and it takes an object. So this object has two fields. The first one is loader. So loader is a function that is specifying what should be imported. So I wrote this fake delay of 2 seconds just to simulate the effects of network, because obviously I'm going to run it on localhost. So after 2 seconds of network time, I'm going to import dynamically an example component. So it won't be loaded at the very beginning. You can actually interact with the app before this component is loaded. In the meantime, React Loadable displays what's in the loading field. Loading is used when this component imported in loader will take more than 200 milliseconds to load, because anything lower than 200 milliseconds will most likely not be noticed by the users, but everything higher than 200 milliseconds will be noticed by the user, and they will see a flash of code. And this is what it looks like. So I'm going to refresh this page, and we see the loading for 2 seconds. And after this, we're going to see this very useful component, which I'm going to talk about in just a second. Over here in the network tab, we saw that the first load didn't include this code for this component. It's only loaded after 2 seconds. So the magic of code splitting is that you can actually get users to your web page and then download the necessary things as they go along. And by the way, a slight note, because I think that someone will ask me about this. This code is not minified on purpose because I wanted to show you guys how much of an improvement you can get. Okay, so we loaded this example component after 2 seconds. And what does it do exactly? So it has a bunch of buttons, which allows us to get a bit of front-end magic, because it allows us to dynamically download code for jQuery, Lodash, Angular, and Moment.js. So this is a magic app because it has all those dependencies. And I think that, I know, some people think that having more dependencies in the code makes them look cooler. So this is what dynamic imports looks like. So we have get jQuery. This is the function which is run when I click on get jQuery button. It will be dynamically imported into our code. And like I said, it returns a promise. So after this promise is resolved, we are sure that the jQuery now has been loaded and we can use it. So for instance, over here, I'm importing Moment.js, and in the promise is going to actually get resolved, and as an argument, I'm going to get the thing that I've imported. So I can actually use it to display a current time. So here's in the action. I'm going to click get time, get jQuery, get Lodash, and we can see that those bundles were created automatically by Webpack and downloaded only when I needed them. So there was no point of making those users wait on the initial page load time, and we can actually get them a better value right from the start. And just to prove it, this is actually jQuery. It could be visible over there. Okay. So there's also this get awesome button over here. And what does it do? So this is a very extreme example, but this is to illustrate a point. The point is that there might be some React components that would be very heavy, and they might not be used by every single user. For instance, you have a very heavy pop-up, which is only displayed in some cases. And this is where this awesome component comes in. And it's called awesome because for some reason, it needs to import a whole of Lodash, Moment.js, Angular, jQuery, and React just to display a single div. So that's why it's awesome. So I'm going to refresh this page now. And I'm going to click get awesome. And this is what the div says. So I needed to download nearly half of megabyte of JavaScript just to load a single div. And this is what the bundle says. So we've created a bundle automatically for us. So instead of making those users wait, like I said, the value was delivered immediately. And after clicking this button, the component is loaded. And another cool thing is because this component has imported all the stuff like Angular, after clicking get Angular, it doesn't do anything. Because this code has been already loaded, so there's no point of making the user re-download the whole code again. Okay, so I think it's all I have prepared for today. So I would like to thank all of you for your attention and not falling asleep. And if you have any questions, you can follow me on Twitter. Please do. And of course, I'm also ready to answer some questions now. Thank you.
Okay, so I do like all what you said, but what's with old good CDN servers? So if we use the official one, CDN server for, let's say, React or the Lodash, we can have cached quite big library already from the other website.
Yes, that's definitely a valid point. I wanted to focus more on what we can do in general with our bundles, right? So those examples of Lodash and other things were just to illustrate a point, because I didn't feel like writing a whole production-ready app just to use it. But yeah, this is certainly a valid point. But for instance, if you use CDNs, right, those users will need to wait quite a bit in order to get those requests. So, for instance, in some cases, it might be actually better to cache them. Yeah, but I agree with your point, but I think it's also a topic for bigger discussion, yeah, I would say.
I think it depends, but it should be like with these tools, like you can choose this, this, and this.
Yes, yes, essentially. Okay.
So my question is, what do you think about code splitting feature? Is it mature enough to consider it safe for production? And maybe you have some insights. What are the possible problems when using it as a developer, as an end user, and so on? Okay,
I think it's ready for production. And I think that it's a great improvement, especially in the context of what you said yesterday about progressive web apps. But the one minor thing that I've noticed, but it could be improved, I've noticed that in some cases, you can actually reproduce an example where you re-download the same components twice using code splitting, because those bundles are, well, not perfect, but I would say that they are production ready, and I will argue that we should start using them.
Working for help with code splitting in Twitter. He usually looks and trying to figure out how it could be improved.
Hi, I have one question. What is the performance cost of dynamic routing in the RAS example?
So if you could just repeat your question, what's the cost of dynamic?
What is the performance cost of the dynamic routing in the RAS example? Because we can see it needs to handle the state of the current routed libraries and things like that. So my question is what is the cost? Because there is no, but how much?
Well, I'm not entirely sure, to be honest. I didn't do any measurements of it. I'm not a big fan of benchmarks that are run on to-do MVC, because everyone runs benchmarks on to-do MVC. I don't think they actually reflect what we have in production. Well, definitely there's a bit of work that needs to be done on Webpack side, but I haven't noticed any performance improvement that are caused by having to download separate bundles. I only noticed the fact that we are getting the value to the users much quicker than we used to by making them download a whole bundles.
Thanks.
Okay.
Any other questions? Okay. So thanks, Tomek, for the...
To później.
Well, one more thing, because we said, and we will be talking about progressive web apps.
Yes.
So it's offline. So this thing will not work because you don't have your application loaded.
Well, like Kuba said yesterday, offline first doesn't necessarily mean that user is actually offline, right? We're going to provide a same experience to those users that have a very good network, and those ones that are actually on 2G. So code splitting allows us to get them the value, for instance, a homepage, faster. And then if those users have to actually do an action, I don't know, fill a form, you can actually make them download the code later, once they actually need to do it.
Okay. So any other question? I don't see anyone. Okay, so thank you, Tomek, for your great speech.